Oh, this is exercise 10G. I'm just solving some more disguised quadratics and also some other trig equations using factorization. So the fact I've got the two graphs at the top, y equals sine squared and y equals cos squared, tells you that there are going to be lots of squared, coses and sines in what we're about to do. So let's crack on anyway. I'll make sure my pen's working. Is my pen working? Yeah, it seems to be. Okay, so we've got a little starter first of all. Just go off the edge of the top of this, but you can see I've got a minus 3x squared. The temptation is just to chuck this into your calculator, and you could chuck this into your calculator. I just really want to show you, the kind of things you're going to get if you do this. If I just chuck it into my calculator like I just said, so menu, and it's on the A button, isn't it? And polynomial degree 2. So I'm going to type in -3. I'm going to type in -2. I'm going to type in 8. And my solutions are, so obviously I need a bracket up for some description here. And my solutions are x equals 4/3. And x equals, what's my second solution say? It says -2. So that's alright. One of them is going to be, that -2 for instance, becomes a +2. And this one, well, I want to write, I'm going to write it over here. I want to write, and it seems quite reasonable to write it. You put the front, this number to the front, and then you change the sign for this number. So 3x minus 4. The problem with this is positive, and this is positive. And if I times a positive by a positive, I get 3x squared. But mine says minus 3x squared. So I can do what I've just done. I can write 3x minus 4. And then I have to effectively take account of that minus by chucking the minus in the front. I'll just show you an alternative to that. At this stage, you can just switch these two around. The one with the negative in already. And make it 4 minus 3x. Notice the x stays in the same place, i.e. attached to the 3. Times by the other one doesn't have to change. And that is a better factorization than this one. But this one is true. This one works. Just notice that 3x times x is 3x squared. I needed minus 3x squared. Therefore, it's a slightly different factorization. One of those two options, either put the minus at the front or switch them around. I don't care which. But really, I want you to take account when you factorize it. It says minus. Make sure you kind of pay attention to that detail. So anyway, we've got some disguised quadratics. I want to really jump straight to this because in the past we've written like dummy variables and stuff. But to be honest, just do this on your calculator. Type in, this is a equal to 3 on the quadratic equation, b equal to minus 13, and c equals minus 10. If I type those into my calculator now, so I need to go menu, I'm still there actually, quadratic, so I'll type in 3, I'll type in -13, I'll type in -10, what answers do I get? I get x1, well this is where you've got to use your brain a bit, just to make sure, so it says x1 equals 5, so we're not going to write that, it says sine, so we're going to write sine theta equals 5, that's my first answer. And then it says x2 equals, what's it say, minus 2/3. So I'm going to write sine theta equals minus 2/3. And I suppose really, because obviously I wouldn't write this down on my page, I would then do a bit of backward thinking and I'd say, let's cheat a bit. Sine theta minus 5, make it look like I've done it myself. And this one becomes 3 sine theta plus 2 equal to 0. So again, allowing for this disappearing, we chuck it in, we've got our answer. One thing to bear in mind is sine graphs look broadly like this. They go up to 1, they go down to -1. And when you get the statement here, sine theta equals 5, what values of theta will make it equal to 5? And the answer is no, nothing will. 5's up here somewhere. So when will sine theta equal 5? It will never equal 5. So here you write no solutions. And I would write since sine theta, oops, got a dodgy line there, is less than 1. It's not technically it's the modulus of sine theta is always less than less than 1. This one is, I've got 3 sine theta plus 2. Yeah, it's minus 2/3, that's right. So I'm now going to do the inverse sine. This one I can do. So menu 1, the inverse sine of minus 2/3. I get minus 41.8. Theta is minus 41.8. Just be slightly wary. It says between 0 and 360, so already I know that's not good enough as an answer. Also, just remember that when you're dealing with sine theta, you get your theta and then you do 180 minus it to get your second solution. So even though it's a negative, I'm still going to do that. 180 minus some minus will give me a plus, so I get 221.8 degrees. So yeah, you end up plus in there even though it said minus. Minus 41.8 is still not good enough as a solution, so I need to add 360 onto that to put it into the right zone. So what is that? So I've got 360 added onto the minus 41.8, and I get 318.2. So I'm going to end up here with 2 answers to 363, because I've got 318 and 222. The other one gave me no answers, so that's right, sorted. Second one then, very similar. We're going to, where's the pen? We're going to chuck these in. We'll pretend we've factorised them again, of course. But when I put them in, my answers won't be x anymore. It will say cos theta equals this or cos theta equals that. Let's put these numbers into my calculator menu. Onto the equals button, polynomial, degree 2. So 6, I'm putting in for the a. I've got a minus 1 and then a minus 1. And this time it says cos theta equals a half. Good, I like that. And the second solution says minus 1/3. So again, we just tidy this up. That's a half. So presumably it's going to say 2 cos theta plus 1 there. So plus 1 there. So minus 1 in my bracket. And this is minus 1/3. So it will be 3 cos theta plus 1. And 2 3s are 6. So it does actually make the equation work. So I've got both of them. Both of them are in between 1 and minus 1. So both will give me solutions. This one, theta is the inverse cos of a half. So let's do that now. We're going to do 1 again. Inverse cos of a half, which gives me a very nice theta is 60 degrees. And remember, as soon as you get one solution for cos, I think, I've got to do 360 minus my solution. So in this case, I get 300 degrees. And it's between 0 and 360, so keep checking those kind of things. And this one, what am I going to get on this one? I've got inverse cos of minus 1/3, and I get 109.5. And again, it's a cos question, so cos is 360 minus it. My second solution, 250.5. Well, it says give it to 1 decimal place for non-exact answers, so I'm on the right lines here, 250.5, and I think that's probably all my solutions. Let's have a look. Yeah, I've got 4 solutions, so everyone's happy. Next equation. Now this is straight away, you're noticing it's different. It's different because no squares in it. It's also different because it says x is between minus 180 and 180. I've got to be careful of that. Now look, it's different, and the technique for these is to effectively move this over. It's tempting to instead try to divide both sides by sine, and lots of people always do that, but when you do that you lose solutions. So the trick is to write 3 sine x cos x. Obviously this is a plus 2, and that moves over and becomes minus 2 sine x equals 0. So everything onto one side. And it says sine, so we always try to factorise. Now this is almost bottom left, so I'm, I wouldn't suggest you do it any other way, this really. I don't think you can use the cheaty button on your calculator. But the good news is there's only one bracket. Sine went into both, so you didn't need to double brackets and stuff like that. Now we've got something times by something equal 0. So either sine x equals 0 or 3 cos x minus 2 equals 0. Now, I can do this one in my head. X equals the inverse sine of 0, and x therefore is 0. And of course with sine, to get your next answer, you do 180 minus your theta. So that's 180 minus 0 is 180. I just spotted this here. Look, be careful. That's allowed to be equal to minus 180. You might think, well, so what? But if once I get my two solutions, you remember I've said to you, you can always add on 360. Or you can always take away 360. And I think by taking away 360 from the 180, I get minus 180. And that's like almost quite unusual to get a third solution. And it's because we're right on the extreme. 180 is in, and minus 180 is allowed to be in as well. Okay, over to this one. The 2 moves over. I get cos x equal to the 2, and I say cos x, and I'm moving the 3 over in one bash, and it's equal to 2/3. So I have to do x equals the inverse cos of 2/3. Let's do it now. Inverse cos of 2/3. I get 48.1. 3 significant figures. I'll give an extra dp, 48.19. What am I got to do with these? Now this is of course cos. This was my sine trick. My cos trick is 360 minus the angle. So if I do 360 minus that answer, I get 311. You just got to get into a habit of doing this second solution all the time. So if I round these to 3 sig figs, I'm going to call this one 48.2. And this one gets one less decimal place. In fact, no decimal place. It's 312. So I reckon 5 answers. Minus 180, minus 48.2. That's interesting. I get there a different answer. Have I done that wrong? I've got 312. So let me have a think about that 2 seconds. Oh, I see. I've just made a daft mistake. Look, I'm only allowed to go from minus 180 to 180. And clearly 312 doesn't go into that. So having got that solution, I then have to take away 360 from it. And if I do that, I will get the minus 48. But now it's minus 48.2 because I've got to, it's really doing 360. It's this number minus the 360. So that actually does work. I'm quite happy with that. I thought I'd made a bit of a mess of that for a moment then, but no, it makes sense. So reminder of these, I touched on this right at the start of a recent one. I've got 5 sine squared x equals 4, so move the 5 over, I get sine squared x equals 4 divided by 5, which is 0.8. Square roots, when I square root both sides, I get the square root of 0.8. No idea what that is. It's, well, as a decimal. I'm going to write a decimal because I get a better feel for it. I get 0.8944. Now, just be aware that it is also minus 0.8944. Quite easy to forget that. So when I move that over, I get x equals the inverse sine of that answer, which is, you wouldn't have known, 63.4. I certainly didn't. And this one is the inverse sine of minus 0.8944. Which you won't be surprised to learn is minus 63.4. Now, look, we've got to get the second answer. 180 minus that. 180 minus 63.4 is 116.6. This one, well, I'm going to have to add, do that same thing. So 180 minus it is 243.4 when I do it. And this one I'm going to have to add on 360 to put it into the right zone. So if you get your answers, I reckon that is about right. Yes, that'll work. And then that's what you've got to do. Exercise 10G, it's the exercises included. No homework, remember. I hope you enjoy that. Best of luck with those. Thank you.